Hi, my name is Stuart, and today we're going to talk about moving .NET CLR applications to Pivotal Cloud Foundry. The world is full of lots of .NET CLR code, but not all of it is suitable for PCF. So things that move well to the cloud in general, and PCF in particular, are websites, web services, and Windows services and other headless tasks with a little refactoring. We'll talk about that. If you have a PCF instance that supports Windows stem cells, you'll find that you can get the Windows 2012 stem cell pretty universally, and more platforms are getting the Windows 2016 stem cell. Particularly, you can get that on Azure and on VMware. In some cases, you may want to run some of your apps from Linux. For example, if you have static content websites written in Angular, or some other SPA, Linux stem cell is sometimes quicker and easier. And in any case, you can freely mix and match Linux and Windows apps in PCF as long as they interact via TCP ports, or better yet, over HTTPS. A little sidebar on dividing up the universe into environments. Environments are sort of a classic idea that represent the flow of code from the hands of the developers into the hands of ultimately the users. And so classically, we make three piles or buckets of environments: the development environment, the QA environment, and the production environment. In PCF, you can accomplish that by either provisioning three different PCF instances, or you can provision those sort of super organizations as orgs within one instance of PCF. And then inside PCF orgs, there are spaces. And so a space is a good surrogate or an analogy for an environment. Common refactorings to take a .NET CLR app that would be a good candidate. And again, that's headless processes and anything with the word web in it. There are three big things that we keep running into on every single project, and we're going to drill down into them in some detail because they're probably the things that will inhibit successful translation of something that runs sort of client server in the data center to running successfully in the cloud, and particularly in PCF. So the three big ticket items are logging. PCF and Kubernetes and other big time clouds like to see log streams going to standard out and standard error. Oftentimes application developers will adopt pretty complicated logging schemes, but in fact, most log hosts of cloud applications are perfectly happy with standard out and standard error. PCF particularly has a subsystem we'll be looking at later called the Logaggregator to roll up all of that output across all of the instances and apps. The next is configuration. If you're a fan, like we are, of the 12-factor app at 12factor.net, configuration externalized is pretty important. But file-based configurations, or having to compile per environment, or worse, having hard-coded paths in your code, are cloud code smells. And configuration should be external, and it should be central. Is error handling. Please go through, especially your old code, especially if you have code written generationally by a large number of developers, and go through and clean up how you're handling exceptions. And of course, configuration, error handling, and logging are all interrelated. So logging strategies, systems that we've looked at, have three big logging problems. They don't log at all, which is kind of okay if you're in a place where you can attach a debugger to it from Visual Studio and see what's going on. But, that's not really good production behavior. And so the second most common thing we see is hideously inadequate logging. And then the third thing is just simply ignoring the logs altogether. A lot of client-server systems use rolling file system logs, and they're great if you are in a position to RDP into the server and find where the application is running in the file system and go look at the logs. But there is no external consumption of those log streams which can offer both developers and IT folks in the business community a lot of value. So PCF goes out of its way to make that better by collecting standard error and standard out from all of the applications and all of the instances. So if I have a website that I've scaled up to 7 instances, it's going to collect and unify those log streams across all my instances. And then the thing about the logging subsystem in PCF is it allows you to make those log streams available to both the tools inside PCF. For example, if you go to the app management screen or the metrics screen in PCF, you can see a lot of valuable things. If you have plugins for your PCF CLI like Top, you can see a lot of interesting things. But even more importantly, you can stream those logs to external consumers that can capture them and keep them for a long time. So if you have compliance programs in place or requirements in place to capture and hold those logs, the logs can be used if they have useful data in them for trend spotting and of course for diagnosing when things go wrong. So here is PCF's classic diagram of their logging system looks like. We won't go through it a piece at a time, but you can read all about it on the Cloud Foundry website. And the important thing is that via syslog drains, you can send things to analysis services like Papertrail and Loggy. And using something called nozzles, you can send streams of data to things like Datadog and other monitoring tools that can do useful things with the logs, like look for problems and raise up events to operators who, there can be an escalation path and have the modern conveniences that business users expect, which is a knowledge of the overall availability and health of the system and the ability to answer the question, what went wrong and how do we fix it? So in order for the logs to be useful, they have to have meaningful content. And when we do migration projects, and I do a lot of migration projects, it's part of my practice, and we look at the logs that are being emitted by applications, again, they're either missing or anemic. And so there's 3 concepts that we want to embed in the folks watching this video's brain about what makes a good log entry: specificity, cross-reference, and type. Every logging system on the planet has some sort of timestamp. Sane ones, like are configured for PCF, that timestamp is in universal coordinated time. Type is important, and really the secret sauce is to stick to the classic idle types. Critical, my app cannot run anymore because. Error, something bad happened, but I'm going to soldier on. Warning, something bad happened and I corrected it, but you ought to know about it. And then debug and trace, which are different levels of granularity intended for the developers to do problem solving and problem spotting. Debug being less detailed than trace. Trace is intended for very smooth granularity indeed. And then lastly, the info category, which is designed to capture log events that are interest to the business. Specificity. Where did it happen? What was the application doing? What data is related to what it was doing when it went wrong, or conversely, when it went right? And so we talk about being able to tie the activity of what the software was doing via cross-references, right? So IDs of rows or records, keys, transaction, correlation keys, and so on are all very valuable to make sure those things are getting emitted into the log. And in the case of exceptions, making sure that the stack trace accompanies the log. And don't forget the happy path. Business transactions, as we've said before, make great sources of fodder for info logs. If they're carefully and thoughtfully formatted, they can go through a log analyzer and then produce interesting metrics and KPIs for the business, including frequency of transactions during the day, total number of transactions, transactions per hour, failed transactions, successful transactions, and so on. Entry and exit in and out of the business process, which gives you an idea about how much time it's taking to satisfy various kinds of transaction requests, and other useful information as to how information and decisions are flowing through the system. Deciding about configuration. In the classic model with configuration per application, and if you're a .NET developer, this means app.config and web.config, right? File-based configuration, not even slightly centralized, right? But that's the classic. It's simple, but it can contain duplicates across configurations, which are undesirable. And by that I mean if there's a configuration value that's used by app 1 and by app 2, that value is represented in each configuration separately, and they can get out of sync with each other. Duck configuration is a popular but somewhat misguided attempt at putting configuration items together that are of a feather, which is to build very few large files based on functional relationships. For example, if you had a bunch of database connection strings, you might put them in one configuration. If you had a bunch of things about different areas on the file system, you might put those into a different configuration. And you might have sort of a garbage collection general configuration that's used by some of the apps that's sort of an arbitrary name value. Very few large files or configuration spaces. They're not very domain specific. And so in that way, while they're better than configuration per application, they suffer from the problem of configuration leakage, which is to say that apps get configuration they don't plan to consume, and apps see configuration that it may not be desirable for them to have access to. So domain configuration is this idea of using the Eric Evans domain-driven design domain concept and designing configuration sources that are domain specific, and in being domain specific, they're probably also tier appropriate. In other words, front ends don't typically know about confidential things because they're hidden behind the facade of services and so on. And they're reasonably independent of each other. And yet you can still have a shared configuration for those scenarios where there are legitimately low security name value pairs that are used by every or almost every application. As you refactor from configuration per application, .config files, to externalized managed configuration, spend some time during the refactoring and think about configuration scope as well. Ideally, the way to do this is to use PCF's configuration service. The configuration service is a, for all intents and purposes, thin facade that uses a Git repository as its source of truth and relative paths from the web root in order to fetch back chunks of JSON that are representative of the configuration. And so, for example, if you had a domain of, say, sales, and you had an environment of dev, and you wanted to get the dev sales configuration, you could go to /dev/sales or /sales/dev, depending on how you want to phrase those things. It's important to note that the normal objection is that because the data is in source control for configuration, that in the production space, it may not be the most secure thing in the world. And of course, the workaround to that is to have a separate source control only accessible to IT and DevOps that serves as its repository of data. And of course, that can be protected in the appropriate ways. An alternative to that, if for whatever reason you're unable to use the PCF Configuration Manager service, is user-provided services. And user-provided services are essentially collections of name value pairs that are injected into the VCAP services environment variable and therefore are available to applications, and that's done through classic PCF binding. In the upper left-hand corner, we have our little settings file that we turn into a user-provided services. You'll notice that the fuchsia bits stay exactly the same and they get nested under a credentials area. And then you have the name for your UPS. And then those things show up in the VCAP services variable. Exception handling best practices. If there is one horrific weakness that we see most often in .NET code, it is misusing exceptions. Try not to catch exception. In an ideal universe, you should be able to predict what exception your code's going to throw. So if you've got a bunch of code dealing with in ADO.NET and you're dealing with SQL Server, you're going to get a SQL exception. If you're using system.net, .http, you're probably going to get an HTTP exception. And so try to catch something with specificity. And in that same line, use try, catch, and finally. And or if the thing that you're creating is implements disposable, put it in a using block so that the finally gets executed and at the end of the using and the object is properly disposed. Please don't throw away the stack trace and all of the beautiful diagnostic information that .NET has built for you by throwing EX. Just say throw inside the catch block, unless you want to throw a new exception, passing the exception you caught as the inner exception and adding more useful information in that process. That's a good thing. And then lastly, logging is your friend. Make sure that you have a consistent way of logging exceptions, whether that's a global exception handler that's going to catch and log all your exceptions, or you're going to do it inside the catch block. In order for logging to be useful, we have to see when things go wrong. Exceptions are the indication of that. Logging is your friend. .NET CLR migration patterns to PCF. .NET Webs and Web Services can be deployed onto one of the Windows stacks, whatever Windows stem cells you have available, using the HWC build pack. And HWC is Hostable Web Core, and it is essentially taking the place of IIS as the web server. So if you have a web config, all of your favorite web config sections will be read by the HWC and honored and interpreted, and with very little trouble at all, assuming that you have externalized your configuration and improved your logging and so on, you should be able to deploy your webs and web services with little or no trouble simply by CF pushing them. Windows services take a little bit more work. Typically, they're used on using the binary build pack. Typically, you need to convert them to a console app, and we'll show you a little sample of those. And most headless tasks or services sort of fall into two buckets. Classic services, which are long-running things that implement some listener that's listening for events and processing the events as they happen. So queue listeners, ports listeners, schedulers, those are all good examples of long-running process. Things that wait until something interesting happens and then they respond to that. Short-run processes like jobs and tasks are also typically built on the binary build pack, and they're typically run using the run task, and they're intended to have a host that stays running all the time as a long-running process, but then that host is told to do units of work using CF run task. But either way, they're going to be console apps. So here's a classic console app structure that you can start with, and then you can move your business logic of your service into. So we have this idea of main, and main wires up a global exception handler as the ultimate something horrible happened exception catcher. We run our main logic in a try catch, and then we do an infinite loop with a task delay and a thread sleep in it to make sure that our process keeps running. And the task delay and system threading sleep are designed so that they're going to use the minimum amount of system resources in terms of CPU execution, leaving more headroom for your listeners to process, but also not consuming much in the way of resources when your listeners are not actively doing anything. By the way, your listeners should definitely implement a unit of work pattern. In other words, they should take an incoming whatever, do something with it, and then get rid of themselves. So let's look at some prototype manifests. I am a big fan of making a manifest for each of my deployable units because there are things that I want to explicitly say in terms of instructions to CF push that I don't want to leave to chance. So an example of that would be how much memory. Here we have two manifest prototypes with different memory requirements. It's good to be explicit about what stack your code's going to run on, about what build pack your code's going to run on. And obviously, if you have services, it's nice to do your service binding as part of your manifest. And if you do that, CF push will respect your wishes and do all your binding as part of the push process. You'll notice that there are lots of other cool things that you can add to your manifest. For console apps, I strongly recommend that you add a minimum of 3 things. No route explicitly, so that they know that they don't have to make a URL for the app. By default, it will, even though it doesn't do anything. You want to specify where the binary build pack should collect the compiled bits from. And so for .NET apps, console apps, either bin debug or bin release, or bin whatever, depending on where you want to get your bits from, should be explicitly specified. And then console apps, you need to tell them what command to run. And you can find the documentation on all these settings on the Cloud Foundry documentation stack. But I thought it was important to point out for console apps, it's good to add some other things. Health checks are something of a mixed blessing. We've had sporadic luck for web apps using the built-in health check mechanism. And so instead, we tend to use an external health monitor like WhatsApp or Datadog or one of those other tools. For console apps, though, the health check type of process works dandy. So if your process exits, it will interpret that as your process failing and try to restart your app. So we should say a few words about routes. For web apps and web services, anything that needs a URL, by default, PCF generates a route. So it takes the app name in the manifest, or it infers the app name if you don't have a manifest, and then each instance of PCF has a unique URL cloud suffix. So for example, your cloud suffix might be my PCF instance 01 hyphen my domain, blah, 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 blah. The thing about that is, if I have a PCF instance, and inside of it are a bunch of orgs, and inside of that are a bunch of spaces, the rule is, because the URL of the cloud instance is going to be the same for all of those things, that you need to have a unique disambiguation to tell things apart. And our recommendation is to provide an explicit host name. And you can do that and give them unique names, and you can use that as the opportunity to also suffix on the environment. So in my example, I am CF pushing my manifest file, and I'm saying that the host name that I want is myapp-dev. And so what I'll end up with is myapp-dev, .url of cloud instance. And then if my app is in integration, then I might have myapp-int. If my app is in QA, I might have myapp-QA, -stage, whatever. And then generally you reserve the non-hyphenated version for production.